But I like to try things even when it's a terrible idea. So here's what we're going to do. You're not going to start posting questions yet. So don't do that yet. And then what I would like you to do is, Preston, you're getting your laptop out? Oh, good. Wonderful. So our fearless TAs, and there's several of them, they are going to help moderate this channel. So let me warn you in advance. Don't be bad today while we're doing the Q&A session, or we will ban you from Slack. Okay? Ban. It's a perma-ban. Okay? Gone forever. So, as soon as Preston is logged in and he gives me the thumbs up, I'll give you permission to start typing questions in. Preston and other TAs, if you guys wouldn't mind, if there are duplicate questions, if you could help us permit them as we go. Just that way we're all on the same page and we don't try to answer the same question twice. They're going to be in, actually, no, we should do this in class response. That's where we should probably do it. Yeah, okay, so it's going to be in class response. Since there were a lot of questions about it on the last quiz we took, there were many passionate arguments made about why installing an operating system should be considered software engineering. So I'm going to give you guys credit for that, okay? So, with that said, I think it's important to understand the distinction between information technology and software engineering, so keep that in mind. That was the distinction I was trying to draw, but I am going to go back and fix that for you. So, with that said, yes, not stupid, irrelevant stuff, guys. Thank you. All right, are you guys, Preston, are you good?
Good as I'll be.
You're as good as you'll be. Okay, so you may now start posting questions that are related to the exam, okay? So, first question is, how to convert, this is not a complete sentence, but I'm going to try. How do we convert base 10 numbers, and the batteries are going out. How do we convert base 10 numbers to base 8 or base 16? Okay, so I'm going to pull up a text editor to do this. Give me just a moment. There's no microphone here. Keep stealing my batteries. Alright, this probably isn't going to work. Alright, so what we're going to do is I'm going to put a text editor out and I'm going to give you a basic idea of how we can go between different number types. So, let's get this on the screen. Okay, so let's say that we have a number like 4,400, okay? You know what, actually, let's use a smaller number because I want to make it something that's, doable in a short amount of time. So let's make the number...
Can you use IntelliJ?
Can I use IntelliJ? Sure. I can use IntelliJ. I can try. I have some problems with the difference between sometimes it won't show up right. I'll try. We'll see if we can get this to work. Yeah, that's the problem I run into. Yep, nope, I'm not going to use IntelliJ. Okay. So, it's not because I don't want to, it's because I have those font problems. So, what was I going to do? I was going to do... Let's do 113. Okay, so we have 113. So I'm going to go ahead and do binary too, because that way we have everything together. So let's start with binary. The way binary works is it's powers of 2. So the powers of 2, and each bit represents one of the powers of 2. So we have 1, 2, 4, 8, 16, 32, 64, and 128, and so on and so forth. So what is the biggest of those powers of 2 that I mentioned?
16.
64, right. So the biggest one I mentioned was 64. So we know that we're going to have the 64-bit in. So it's going to be 64 plus And then in this case, it's going to be plus whatever's left over. So the leftovers are going to be 36, 39, 49, right? Is that right? Yeah, 49. So instead of 49, we could rewrite this as another power 2. What's the next power 2 under 64? 32. So we cut it in half, and that's 32. So we can actually pull 32 out here. And then this number is going to become 17. I'm just having all kinds of problems. 17, right. And you probably see where this is going. What's the next power 2? 16, right? So this is going to be 16, and then that's going to be plus 1. And that is our number in binary. So if we go back and we represent these in binary, that's going to be 64, 32, 16. There's nothing for 8, there's nothing for 4, there's nothing for 2, and then there's 1. So that's how we convert it to binary. Is that pretty straightforward? Anybody need a follow-up on that one? All right. So it is definitely true that octal and hex are more of a challenge. So let's look at an octal number. If we were to turn 113 into octal, octal works in powers of 8. So that means we have 1, 8, 64. Right? Everybody understand why that is? 8 to the 0 is 1, 8 to the 1 is 8, 8 to the 2 is 64. Good so far? Okay. So that means, how many 64s can we pull out of 113? Just one. We can only get one 64. So it's going to be 64, and this is actually going to kind of mirror binary. 64 plus 49. So we can't get any more 64s out. How many 8s can we get out of 49? Somebody said? Right, we can get 6. We can get a 48 out of there, right? So it's going to be a 48. And then there's going to be 1 left over, right? So this is our breakdown. So now we have to actually turn this. Now we have to actually turn this into the octal representation. So we had 1 64. We had 6 8s. And then we have 1 1. So this is the representation of the octal. Okay, so now let's go to hexadecimal. So in hexadecimal, let's see, what are we going to have? We're going to have 1, 16, and 256. So obviously we're not going to get a 256. So how many 16s are there in 113? 7. There's 7 16s. So if we do 7 times 16, that's going to be 80 plus 32, which is 112. So we have 112, plus 1, right? Okay, so 112, we had 7. So in hexadecimal, it's going to be 7 16s and then 1 1. So that's the hexadecimal representation. Okay, does anybody need to follow up on that? Yes? For octal, it's powers of 8. And then, so the way it works is binary is powers of 2, octal is powers of 8, hexadecimal is powers of 16. So that's the key starting point. Does that make sense so far? So hold there for a moment. So if we're doing powers of 8, then what are the powers of 8? We have 1, we have 64, and we have 1, 8, and 64, and then whatever 8 times 64 is, which I don't remember.
And then how many get 48? That's not the power of 8.
Here's how it works. First of all, you've got to go to the highest power of 8 you can actually pull out, which right now is 64, right? And you say, how many of those can I get out? You have to, and in the case of 64, you can only get 1, right? And then you take whatever's left, in this case it's 49, and you go down to the next power. You say, okay, 8. How many 8s can I get out of 49? And the answer to that is 6. And that's why we put 48 here. Does that make sense? Is it starting to come together? So for every power, you see what is the max number you can get out, but you always start at the top and then you move down. Good? Okay. Yes?
Can I ask you about base 10?
You can ask me about base 10. What would you like to know about
How
it?
would you take do base 10 and like convert it?
Well, oh, you want to convert it the other way.
Yeah.
Okay. Since I have a list of questions, make sure that's in the queue, and I want to make sure I'm being fair. So I'm going to go according to the queue.
I have a question.
Holy God, there's a lot of questions here. Yeah, go ahead.
I'm not understanding how on line 3 does turn into an action.
Let's see. You're not understanding on line 3 how we're getting that binary number.
No, I get that. I was going to say, I'm not understanding how the computer interprets that and makes it into an action.
How does it turn it into an action?
Yeah.
Oh, certain numbers represent different instructions. That's really what it comes down to. So, like, basically, there's a number that means add, and there's another number that means subtract, and stuff like that.
That's a lot of numbers. That's a lot
Yeah,
of.
it's a lot. Yeah. All right. So it is optional for you to be here. So if you don't want to listen, you want to talk, that's totally cool. But don't do it here, please. Okay?
He's so nice.
It's pretty
Pretty
stupid
please?
question, right? Nice.
Yes. Is this a follow up for this one?
Yeah.
Okay.
What were the names for line 6 and
I hate the abstract.
Oh, the question was, what are the names for these?
Yeah, like base 10.
Yeah, so the number system that we use as human beings is base 10, right? That's 113. Then on line 3, we have binary. On line 6, we have octal. And on line 9, we have hexadecimal. Okay, so the next question is example of the long answer. Oh, yes, I did promise to give you an example of a question that you would have to answer that is like a problem-solving question. So I read these earlier today, so I can give you one that's not actually on the example, but it'll give you an idea.
Go ahead and look up logic.
So if I said
Logic? Is that what it is? Logic?
one example of a problem I might give you is, here is a string. Reverse this string. Write an algorithm to reverse a string.
Yeah, there we go.
And then I gave you some functions that are in a string, like the character acts and stuff like that. And I told you that you had the link and things like that. You should be able to reverse that string. That's an example. So, basically you would have to go through character by character, and you would, actually you need an array for that, so we have to go with arrays again. So that's maybe, that question's too hard. That's not, yeah, we wouldn't actually have that on the exam.
It's very
What's that?
rich. I don't think,
Yeah, you don't need a for loop to do that.
Yeah, they don't.
You know what, actually, let me give you guys some.
basically, if you hook up two capacitors next to
And this
each
one
other,
is able to do very small changes.
it doesn't read it. It's all, that requires a computer. A computer has to have a sensor to read it, right? We're not talking about sensors.
All right, I'm going to come back to that one. I'm going to let our friends who are the TAs come up with a question that is not on the exam but is within the bounds. So give me a minute here. Yes.
Do we get a sheet of paper with like lines of codes that we don't have to memorize?
The question was, are you going to get a lot of sheet paper with stuff so you don't have to memorize stuff? Anything you need, like any API stuff you need, we're going to give you.
Can we get that ahead of time?
We wouldn't. So my plan is not to give it ahead of time. There's lots of stuff out there. Anything that's in the documentation that for Java, it's all there already. So you can take a look at like the string API, the integer, all the stuff that's in the slides. All those APIs, those are all the possibilities. Okay.
So you would give us all of those.
So any of those that you need, we will give you. Yes. Okay. But yeah, we would give you any of those that you need. Yes. Is this a follow-up to the question here? So the question is, am I going to release a practice exam? And no, the answer is no, I'm not going to do that. That's what this question and answer session is for. I also have not taught this class before, so I don't have any old exams. But do ask any questions that you have. So, okay, let's see here. What's next? Let's see. I keep getting... the question is, how do I exit a while loop? Asking.
That's necessary.
Okay, that sounds like a project question. If you want to exit a loop, you can use a break statement. That's kind of an exam type question. There's a break statement that we talked about that breaks out of things, and that includes this.
the logic without using analog?
Okay, when calculating integer overflow, do you add the excess to the negative side of the boundary and vice versa for underflow? Can you do an example? Yes and yes. So let's do an example. Uh, let's start.
I don't get this
Where
enough.
am I? Okay, there we go.
So you don't have to understand.
So let's say we wanted to do an overflow example. So let's say we started with the number 120, and then we wanted to add the number 57 to it. Let's assume this is a byte. Here, we'll make that clear. This is a byte. So what is the byte's upper boundary? Do you guys remember? 127. So a byte's upper boundary is 127. So if we add 57 to it, normally that would be 150 or 177, right? If we added 57, but of course we're going to run into overflow here. So what's going to happen is that we're going to take the easy way to calculate this is to remember that when you go above the mark, it basically becomes negative 128. So you have you're basically going to be going. Basically, what you're going to have is you're going to have. Let's see. I think the shortcut. I'm not gonna take a shortcut because I don't want to mess it up. So if you went, let's say that we added just the 7, right? We'd be right at 127. We'd be right at 127, and then we'd still have to add 50 more, right? If we added another one, we'd be at negative 128, and we'd still have 49 to add. So you probably see where this is going. So if we add 40 to this, then that's going to be 88, right? If we add the other 9, then that's going to be negative 79. And somebody can check my math on this. But for overflow, I'm just trying to make sure that if you add 57 to 127, you get negative 79. I think that's right. But we should double check my math.
I don't understand what's going on.
So basically what's happening here is that it's overflowing, and it cycles right around to the back to the other side, and it comes back. Have you guys been able to check that for me?
What exactly are the numbers?
The numbers are, we're taking 120 and we're adding 57. And I just did this in my head. I just want to make sure that I'm not leading people astray, because I did this in my head on that quiz question and I messed it up. Or you can double check the math. You're getting negative 78? I'm off by 1. That figures. That's what happened last time, too. Okay, so somebody said it's negative 78, so that sounds about right. So I'll...
He's adding 120 plus 1?
I don't know. Like,
all right.
I think.
So.
I guess
you guys probably
127. It flips over.
Negative 78. So
Yeah.
I was off by 1, but hopefully this is showing you how to
Works like this.
overflow is just in the opposite direction, right? So if we took this and then, and then we added, right? If we added 57,
Yeah,
we add
it's
50, and that's going to get us to negative 128, right? If we added, if we subtracted 50. If we subtracted another 7, basically what we're doing is for the first one, if we subtract another 7, that's going to get us to, we're going to start subtracting from the other side. So from 127, which is the other end, right? From 127, if we subtract 7, we're going to get 120. So do be careful of the boundary and play around with these, but that should give you good accuracy. Yes?
Do you add it and then it flips a sign? I'm so confused.
So let's see. I want to make sure I'm careful with how I tell you this. So the 128 boundary. So if we have 128 and then we add 1, and we subtract 1, that should give us 127. I'll double check. Let me come back to this in a minute. Because the boundary is tricky, and I don't want to give you. The guys don't want to take you up the wrong path. So.
Don't put it on the test.
I'll make sure you guys have the right information in a minute here. I just don't want to confuse you by saying the wrong thing. I can do it in my head, and then if I don't tell you right, then I'm going to confuse you. So let me come back to this in a minute.
I want to know. It's like bothering me.
So let's see. Why can't you make bitwise logic mix bitwise and logical operators? And switch, why can't... Oh, I'm sorry, there's 3 questions here. I'm going to take one of these and I'm going to put the rest of them in the back of the queue, so I apologize if you wanted me to answer them all, but I kind of got to answer them one at a time for each person. Why can't you mix bitwise and logical operators? You know what, this is a short answer. Why can't you mix bitwise and logical operators? We haven't covered the bitwise operators yet, but we are going to later. But the short answer is because Java says so. In other languages, you can't mix them. There are languages where you can mix them. Did you have a follow-up? Or?
Everything works.
No, I want to do the white.
Oh, yeah. I can try.
Oh, no, I'm going to figure this out first. Hold on, let me read it.
I think the answer is no. I'll keep trying to hunt for it, but I don't see Zoom on here. I'll try and find a way to Zoom pretty shortly here, but it doesn't look like I have functionality out the door, and I'm not seeing it here. Maybe it's in the preferences? Let's try Control Plus. That works. Why? Why would you do that to me?
Your keyboard must be.
Yeah, I guess so. Oh, there we go. Okay. All right. So yes, I can. I like it. Okay. David is what I will come back around to your other 2 questions. Well, I'll answer this one in a switch, and then I'll come back around to 3 if we have time. In a switch, why can't case expression be a variable? The reason is because what's going to happen is the compiler is going to compile down the values. It's going to compile down the values, and it's going to use literals in the code itself. So the code instructions actually get translated into the numbers, not into variables that hold spaces. That's kind of a technical answer, but that's why. So can you please re-explain the call stack? Yes, I'm going to pull out the lecture slides for this because I think that's going to be a little bit easier in this case. So I'm just pulling up the call stack slides if you want to follow along. There it is. Okay. Okay, so the call stack. Basically, the idea of the call stack is that we have, every time we call a function, it's going to create an entry on this thing called the stack. And the stack basically holds all the information that's required to execute a particular method or a particular function. So when we start a program, it has an empty stack. When we enter any method or function, and that includes main, it's going to create a call stack entry. It's going to create a place on the call stack that we can use. That, in this case, the main call stack is going to hold whatever variables we have in main. So this is going to hold args, and it's also going to hold the greeting variable. Then, when we execute this getGreeting function, that is going to add another entry to the call stack for getGreeting. And it only has 2 variables. It has, and those are from the parameters, first and last. Once getGreeting is done, then this block will disappear. This getGreeting block will disappear, and it'll go back to main. So whatever function it's in, there's going to be a block for each one. So if we called another function from getGreeting, we called it, just trying to think of a name. We called it roll the dice or something like that. And there would be another block right here that said roll the dice. Yes. You have a follow-up? Yeah.
I'm just curious. Why does it always go to main first? Why doesn't it go to, say, the getGreeting?
Question is, why does it always go to main first? The answer is because that's the way that the Java stack is written. And just the Java virtual machine, for whatever reason, and that's the way it is in C and C++. Main is a pretty common name for the entry point to a program, and usually you use a name for that entry point. You don't use you don't go according to what comes first. Now that's not universal. There are languages where that can happen, but generally, especially in the C family languages, that's what they do. Hold on just a second here. He's finishing up. Go ahead.
Does it have to be named like the first one?
The question is, does it have to be named domain? And the answer is yes, it does have to be named domain. Yes?
Is there any way you can redefine that entry point?
Is there any way to redefine the entry point to main? I don't think so, but I'm not 100% sure. I know that you could, if you wanted to, so actually, you can't redefine the default entry point. What you can do is you could create a special class and you can tell the Java virtual machine to execute some other function. But as a default, you can't change the default itself.
Thank you.
You're welcome. Okay, so does that clear it up for the call stack? Any follow-up questions for the call stack? Because there were a bunch of, plus like thumbs ups on that one. So yes, sir.
What was the, where does it say args under main?
Oh, the question is, why did it say args under main? And of course, I've taken it off the screen, which is nice and convenient. Let me pull it up again. So under main, if you look, the parameters that get passed into main, whatever they are, like from the command line, that's what args is, and that's why it's inside of, because that's what gets passed into main. It's in main's call stack. Does that answer your question? Okay. All right, let's see what else we got in the list. And I got to get back to the binary question. Or not binary, the overflow question. Let's see. Question is, what kind of pseudocode would we have to write? So you are not, the only limitation on the pseudocode is that it has to make sense. So here's the easiest thing to do. The easiest thing to do is write Java, okay? We don't care if you have a brace out of place. We don't care if you're missing a semicolon. If you just write the way you would write Java, and you make sure that it makes sense to another human being who's reading it, and that it's clear and concise, that is the most straightforward way to do it. So we don't require the code to be syntactically correct, but the syntax you know up to this point is Java. So that is the common denominator. You are welcome to use Java-based syntax. So lacking anything else, that is my recommendation. Other than chapters 1 through 6 on Zybooks, what else are we going to be tested on? I want to point out that it also includes chapter 7, which is just a short little chapter on objects, and that's what we covered last time. There's Zybooks. You are responsible for the stuff that we posted to VineTap. You're responsible for the stuff that we have talked about in lecture. The exam will focus on the content of lecture, but the Zybook stuff and the Cengage book stuff are fair game. Anything we've done in lab is fair game. Anything we've covered in this class is fair game. But it will be focused largely on the stuff we have covered in lecture. Do you need to know how to convert base? Yes, you do need to know how to convert base 10 numbers into binary, base 10, and base 16, which we have done an example of. Do we have to need to know anything about base 8 or base 16? You have to know what they are, and you have to know how to convert between. So, and we did an example earlier, and I believe somebody was posting another question to go in the other direction. Is there a practice exam? There is not a practice exam. And that's for a number of reasons, not the least of which is that we don't have any previous exams. But you are welcome to ask any questions you like. Can I please explain the types of exceptions we should know? You are not required to know any specific exceptions. You need to know what an exception is and how it works. You don't need to memorize any of them. If you need an exception type on the test, we will tell you all about it. If you want to read the list of exceptions that exist in Java, there is Java documentation, but there are literally hundreds of them, and you do not need to know them by heart, okay? Hopefully that clears up that question. Let's see. It's through chapter 7. Yes, thank you. I can't figure out how to avoid error being thrown for non-integer inputs. That is definitely something that will be a project-based question. Any recommendations? So anything that's project-based, I'm going to skip and we'll come back to it. We will try to answer your questions, but this is like I'm trying to focus on the exam questions here. To keep redoing try catch until it doesn't catch anymore, would you need to do a while loop? If you wanted to keep doing it over and over again, then yes, you would need a while Let's see. Okay, no, we're good. Let's see. Oh, Preston already answered that question.
As long as
What does the tab scare? What does the tab scare students for? So the tab scare students is stuff I talked to you about last time. I'll actually go ahead and go through it now. So mostly I'm trying to make sure that you know that I really don't want you guys to cheat, please. And I find that the best way to keep people from cheating is to scare them into not cheating. I'm not perfect, and nobody here is perfect, and that's okay. We don't have to be perfect.
Do you think cameras
Your
can do that?
integrity is on the line in this exam. Please
Are you
don't
asking
throw it
something?
away. All of
Do
you
you think
have
cameras can really
signed
do
the
that?
oath
Who's that?
for UF students. All of you are UF students and have agreed to abide by the university's rules, and I expect you to do so. And that means
I would've
no
done.
outside sources. That means no changing tabs in the middle of the exam. It means no sharing the password with anybody outside of this room. All of those things apply. Yes, do you have a question? If the internet goes out, that's a fantastic question. If the internet completely goes out, I don't know. I'll probably no. That's not going to happen. Don't even bother clapping. You'll just be angry. No. If the internet goes out for the whole hall, or we lose electricity or something like some cataclysmic event, what I will probably do is I will have TAs rush over to the CISC building and use my computer to print out more copies of the exam on paper so that we can complete it. So, but hopefully that doesn't happen. I am going to have some paper copies because I'm sure some people will not be able to get on the internet, and so we're just going to have paper copies to address that particular issue. While I'm thinking about it, there were a couple of people who said, "Hey, I want to take it on paper anyway." So if I gave the option, if it's a lot, then I can't do it. That's the short version because it costs too much to print the paper, and nobody wants to go pay for an exam packet at the bookstore. Do you? Anybody want to do that? Probably not, right? Because that's what people have been resigned to, is that we have to make people pay for paper exam packets in some cases, because printing is expensive. So if I gave people the option to take the exam on paper, how many people would want to do that? Okay, so it's way too many for me to give people the option. Okay, that's the answer. Okay, thank you. Well, I mean, if it was only like 3 or 4 people, I would do it, because like it's just a handful. But I really can't extend the option if I can't extend it to everybody. And there were way too many hands up for me to do that. How many people would be okay with paying for the exam packet? I think they're like $5 or something. I don't know. It's been a long time since I bought one, so it looks like one or two people. Can you use a calculator? Okay, that's a good question. The question was, can I use a calculator on the exam? If you bring a 4-function handheld calculator, yes. 4-function, not scientific, not with binary and hexadecimal in it. Yeah. 4-function calculator. Yes.
Will the test give instant feedback on the multiple choice answers?
Question is, will the test give instant feedback on the multiple choice? And the answer is we're not going to give instant feedback, but we will release feedback to students eventually. But there are some issues with instant feedback, like if there's a problem with a test question and we get instant feedback, that can cause all kinds of problems. There's probably not. It's probably fine, but we're going to go over the data and make sure it's right before we release the answers. Unless there are follow-up questions, I really should start going back to this. But if you have a follow-up question based on what we've said so far, that's okay. Yes?
For the questions on the test on Canvas regarding pseudocode, will the answers be like they have to be in a certain format, or are you just going to grade them?
The question is about the pseudocode questions. Those will all be graded by hand. All the pseudocode and short answer questions will be graded by hand. This is a follow-up question?
Yeah.
Okay, go ahead.
Asking about the time, is it like the whole class period?
Yeah, you have the whole class period. So there should be plenty of time. I'm not planning on my plan is for the average person to take less than 1 period to finish it. That's my goal. It might take longer, so don't plan on jetting too quickly, but in an ideal world, that's what I would do. Let's see. Okay, so I answered the scare tab students. Scare students tab. Can you simulate a practice question that would be on the test? Yeah, I think that's in our list. Are you guys still working on something? Or?
Why is there a tab with my name on it?
Oh, you sent me one on Slack.
Is there
Okay,
a tab
perfect.
with my
Thank
name
you.
on it?
Very simple.
Okay, so
Right.
here's an example. This is a good example. Write code that takes 4 numbers from the user, calculates the average, prints the average, and then prints the range and the outputs in sorted order. So in other words, from like greatest to least. Okay, that's an example. So we're mostly looking at your ability to manipulate information, to be able to take data and spin it around and kind of poke it and calculate stuff from it, right? So it's not going to be anything super complex. It's going to be something that's within the realm of what you guys are capable of doing. So I'll read that one more time because I know some of you guys want to use this as practice. It is write code that takes 4 numbers in from the user, prints the average, prints the range, and prints the numbers in sorted order.
That's a test question?
That's an example that you could use if you wanted to practice. Yes, that's an example of what one of those pseudocode questions would look like. If you want an example of the quiz questions are a pretty good way for you to estimate what, like if you took some of the harder quiz questions, those are a good approximation of what you would expect on the exam.
So that's a question that we would. Do you want us to print out the index within the range?
That is a question where we would want you to write the code for that. What I just said.
Well, that's not too bad.
No, it's not too bad. It really isn't. Yes. You know what? I will post it on Slack. Does that sound good? Okay, I'll post that one on Slack. Let's make sure we get the language just right, and we'll post it on Slack. Okay. Let's see here. I gotta go back to the in-class response. Okay. Let's see. Where did I leave off?
Oh, what? We would be for time range and then we would
How many questions? This is a quick one. Questions on the exam. There are 18 questions, 16 multiple choice, multiple answer, 1 short essay, and 1 problem-solving question.
Wait, we did range? Have we gone over that?
That was like a 4-line range. Like, did you make
Yeah, that was like a Python.
Yeah,
That's like a COT question. I've never seen this shit.
It's the same thing. But it's literally the same thing.
What's that?
You make
I
a
don't know.
4-line range.
Does that work in Java?
Frame out.
Does that work in Java?
Yeah.
Yeah, I'm only going to ask you for positive numbers and binaries
You
at
make
this point. I won't ask anybody for negative
You make
numbers.
I an integer. You make it and then you make the range.
Can you explain short circuit evaluation? Sure. So short circuit evaluation is when we have 2 conditions, right? Like if we have something and something else. For and, both things have to be true. If we can figure out that one of them is true, that one of them is false, we don't even have to look at the other one, because if one of them is false, it doesn't matter what the other one is, because it's not going to pass, right? Because they would both have to be true. And or is the opposite. For or, if any of them is true, then it doesn't matter what the other one is. So that's short circuit evaluation. Yes?
For the question that you said that if the user gives you like 4 numbers, but you don't know the 4 numbers, I know how to do it in Python, but I've never seen this in this class.
Yeah, well, so the question is, I've seen this in other places, but I've never seen it in this class. And, taking in the input from, you guys know how to take an input from the user, right? You know how to read in numbers?
Yeah.
And you know how to compute an average, right? You just kind of add up the numbers and divide by 4, right?
Yeah, but if you don't know how many numbers the user is going to input.
Oh, we said they're going to put in 4 numbers.
4 for sure, okay.
Yeah, in this example, yeah. So this isn't the quiz. Whatever it is, it'll be finite, right? We'll tell you exactly. We might say 10 numbers or something like that, but it'll be the same idea. Okay?
Could have used like a detection.
Okay, so let's see. That was short circuit evaluation.
Self-content.
We're going to be able to email
I gotta
questions
think
over
about
the
that.
weekend.
Yeah.
I mean, you certainly can email them.
One of the homeworks.
Whether or not we'll answer, sorry, I'm not trying to be a jerk. Sorry, that really
I've done it
wasn't my
before, but not in
intention.
this class. So
I don't
I
mean
know
to be
how
a
to
jerk,
do
it just
it
comes naturally.
for I don't know, in Python. Like,
So,
I don't like Python too much.
I'm going to try and answer questions when I can over the weekend, but I don't want my wife to murder me in my sleep, so I'm going to try and not work the whole weekend. I assume that similar things are going on with the TAs. They may not have families. Well, some of them do. You know, they're not all orphans. But you know, they're gonna have things to do. Okay. They're gonna have things to do. You know, so I think we're all gonna do our best we can. But I wouldn't expect really rapid response over the weekend. I think we're gonna get to it as we are able. I answered, yeah. We're only gonna ask you to do number conversion and for positive numbers, because negative numbers they're a little bit too much. Did I win the seat? Wait, no, this scrolled up too quick. A friend asks whether a file reader will be tested on the exam. I don't think we didn't even cover file readers, if I remember correctly. I don't think we did, so no. You know, we haven't gotten to that point, so we're going to do file stuff a lot later. If the TAs have time, if they're reasonable, oh, never mind, that's an answer. How do you use base 10? If you don't know how to use base 10 by now, you're in trouble.
When I accidentally was typing when you were doing the other way.
Okay.
I was asking.
Oh, you're asking me to do it in the other direction. Okay. Okay, so that's good, because as I was going to say, you're in rough shape. How do I count? What is the number 10? Yeah, so, okay. So, I'm going to, before I go away from this scaring students tab, please don't cheat. Oh my God, I hate bringing people up on cheating charges. It's so miserable. I do it because I have to, but I really don't want to do it to anybody. This is really important. If you talk during the exam, I will give you a 0 on the exam for talking, okay? So you have to be absolutely silent during the exam. All right, I think that's enough staring now. So we were going to look at converting in the other direction, like if we have hex. Let's do 1 hex, 1 octal, and 1 binary. So let's start with a hex number. Let's say we have A4, okay? So here's what you have to remember. These are also powers of 16. So the furthest to the right is 1. It's 16 to the 0. The next one is 16 to the 1. So that's 16. And after that, it's going to be 256 and so on and so forth. So we have A, which represents the number of 16s. Do you remember which digit is A? A comes after what in hexadecimal? Comes after 9. So this is basically 10. So we're going to have 10 times 16, because this is the 16 to the 1 digit. So 10 times 16 is 160, right? So we have 160. Here, I should add the notation here just to be clear. OX. We have 160 plus 4 times 1. So if we were going to break this down, this would be 10 times 16 plus 4 times 1. And that's because A is 10, so that's the 16's place is 10. The 1's place is a 4. If we had another digit on this side, it would be 256, which is the next power of 16, and so on and so forth. So if we take these numbers, what we're going to have is 160 plus 4, which is 164, right? So that's hexadecimal. And we're going to do something similar for octals. So if we have 079, oh no, I can't have a 9 in octal, 076, then that's going to be, the places are 64, which is 8 to the 2, 8, and 1, right? So 1, 8, 64. So we have 0 64s, and then we have 7 8s. So what's 7 times 8? That's 56, right? So we have 56, 7 times 8 plus, and then we have 6 times 1, which is 6. So I'll go ahead and rewrite this. This is going to be 7 times 8 plus 6 times 1. And if we do that, that'll be 56 plus 6, which is 62. So 076 in octal is 62 in decimal. So those are our hexadecimal and octal examples. So let's do one more, and let's do binary this time. Okay, so in binary, their powers are 2, so it's going to be 1, 2, 4, 8. So we have 8, 4, 2, 1. So that means we're going to add 8. We have 1, 8. We have no 4s. We have no 2s. We have 1, 1. So 8 plus 1 is 9, right? So this one's going to be 9. Okay, so that's the calculations in the opposite direction. All right, how much time do we have? We have 3 more minutes. Okay, let's see if I can fit in another question. Can you explain the file not found exception? It means a file was not found. Sorry, I mean that's just what it means. That's exactly what it means. It means it looked for a file and couldn't find it. How do you make conversions using base 10? I answered that one. Okay. Could you explain how to calculate quiz 4? I don't understand this question. Does anybody want to clarify for me? No? Going once, going twice, gone. Okay, what does integer.parseInt do with a scanner in a try statement? The integer.parseInt method, what that does is it'll take a string and it'll turn it into an integer. That's what that function does. So if you scan something in, and then you put it into integer.parseInt, it will turn whatever you scan in into an integer. Let's see, base 10. What is the best way to study for this exam? Best way to study for this exam. This is a really great question. Go through the lecture slides. Please make sure, read them. You should understand everything that's on the lecture slides. That is easily the best way to study. If you go through all the lecture slides and you feel really good about it, skim through the sections of the book and make sure you understand all of that. If you haven't done the exercises in Zybooks and in MindTap, do those exercises. They will help you. Those are the best ways to study. And if there's anything you would like to know, I will stick around. Take care. I will see you on Tuesday.